Hello, hello. Hello. Okay, hi Abdul. Hi. Is everything clear? Everybody join. Okay. Let's wait for 2 minutes. Okay, and then we'll start the session. Let me know if the audio is clear and if the screen is clear. Okay. Then we'll start doing the questions. So our topic for the day is some basic concepts of chemistry, and we are going to do a DPP. Okay. And a total of 30 questions we are going to target. Okay. So in this 1 hour 10 minutes or 1 hour 15 minutes, we are going to do important questions. Okay. Top 30 important questions for some basic concepts of chemistry. Okay. Kanishka, good evening. Abdul, good evening. Okay. Okay, let's start. So Kanishka, Abdul, and whoever is in the session right now, okay, just try to answer all the questions you can, okay, and if your answers are wrong, try not to retract or delete those questions, okay, or those answers that you have answered. Please make sure, okay, that you are not cheating. If the notes are in front of you, it's fine, okay. 3 people are now, okay, good. Okay, so this is the first question. Let me just start a timer for you, okay, and for every question we are going to give you 1 minute, okay. Read the question carefully, okay, and try to answer. I remember there is a 1 minute lag, okay, due to some internet issues. There is just 1 minute lag on the live and what you are receiving, okay. So I will be answering your questions, but after 1 minute. So make sure you see this. Okay. Now Abdul, Kanishka, whoever answered the names, okay, try to do this question. Calculate the number of moles, okay, you have to calculate the number of moles. Okay, the timer got out, okay. Anyways, 20 seconds are there. I'll give you 20 seconds to read this question and do it, okay. Now, calculate the number of moles of oxygen in 1 liter of air containing 21%, okay, pause, right. Now, so calculate the number of moles of oxygen in 1 liter of air, okay, containing 21% oxygen by volume under standard conditions, okay. So can you tell me what is the importance of this word? What is the importance of this word? Standard conditions. Okay, Abdul has answered 1, okay, good, 1. Somebody, Kanishka is saying option number A. Let's check if option number A is the right answer. Okay, what you need to do, calculate the number of moles of oxygen. So we have to calculate number of moles of oxygen in 1 liter of air. Okay, now remember, we have 1 liter of air, not 1 liter of oxygen. Okay, in this 1 liter of air, okay, 21% is oxygen. So 21% of 1 liter is how much? You have to just multiply this ratio by 0.21, okay, and once you multiply this 1 liter by 0.21, you will have 0.21 liter, okay. So now we have 0.21 liters of oxygen, and once we get this, what we will have? We have this much liter of oxygen. Now, what do we need to do? This is the volume of oxygen. Look, there are 3 ways to find moles. First, from the number of particles. Second, from the weight of the substance given, and third is what? The volume itself. And I have asked you, what is the importance of this standard condition thing that is given? Can you tell me what is the importance in the comment section? Okay, so the importance is for this is called STP, standard condition of temperature and pressure. It says that, okay, it says that 1 mole of any gas is going to acquire a volume of 22.4 liter. Okay, how much? 22.4 liter. Okay, so it means 22.4 liter is 1 mole. Then how many moles are there in this one? 0.21 liter. Simple answer. So the number of moles is given volume, okay, number of moles given volume upon the volume of 1 mole, that is 22.4. That will be answer. Okay, let's calculate how much it is. So 0.21 divided by 22.4. And remember, I am using calculator, you are not supposed to use calculators, okay, because I am right now just teaching. Now the answer is somewhat 0.00093, okay, you can see the answer is 0.0093. So option number A is the right answer. I hope everything is clear, right? Okay, now let's go on to the next question. Question number 2. Percentage of SE. Okay, now we have 6 people. Everybody just try to say something, okay, when you have joined the session, say something, good morning, your name, whatever, anything, okay, just say it so that I know that you are in the session and you are trying to answer things. So this is the question in front of you. I'll start the timer, okay, 1 minute. Read the question carefully, okay. I will just go out of this frame. I hope I am not like hiding anything. So percentage of selenium in peroxidase anhydrase, I don't know. We don't know what is this compound, peroxidase anhydrase, okay. Enzyme is 0.5% by weight of this particular thing. Then minimum molecular weight of peroxidase anhydrase enzyme is. Try to find out this answer. Everybody who is watching, comment down your names, good evening, whatever, okay. It tries to motivate me, okay. So it feels like I'm not just here teaching to a screen or a camera, okay. Good evening, okay. Good evening, Priya Jyoti, okay. Kanishka, I have seen you yesterday. Priya Jyoti, I have also seen you yesterday. Okay, and it's good that you are attending every session. Make sure you attend every session. And if you want some of the improvements, if there is a lag in the quality, you just let us know. Okay, try to answer. We have 1 minute. Okay. Got it. So just keep it here. Okay, now let's see. The question is, we do not know what is this peroxidase anhydrase. Look, they are not going to give you some compound which you even don't know about, okay. So, okay, no answers are there right now. Try to give the answers, okay. So option number, so question number 2, percentage of selenium in peroxidase anhydrase enzyme is 0.5% by weight, okay. It means selenium, okay, whatever the percentage of selenium is 0.5%, okay, by weight. It means 0.5%, okay, of this compound. I don't know, I'll call it the compound X, okay. 0.5% weight of the compound of X is equal to how much? Is equal to 78.4. Sir, why 78.4? Remember, we have some compound, okay, and in that compound we have selenium, right? Okay. Now, if something, suppose the compound is selenium X43, whatever this is the compound, okay. Now, I want to get the minimum molecular weight of the peroxidase anhydrase, okay. I want to get the minimum molecular weight. It means it is asking us, okay, molecular, not molecular mass, okay, molecular mass. Now, see, if this particular thing is 1 atom, then everything will be simple whole number ratio, right? Okay. Now, the minimum molecular weight will come from this selenium ratio. Got it? Clean. Oh shit, I cleaned everything. Okay. Now, 0.5% weight is this. 0.5 weight percentage of X is what? 78.4. Okay, we can assume minimum weight. Okay, there can be more number of selenium atoms, but we are assuming the minimum. Okay, so minimum weight is this. Now see, 0.58%, how can we calculate 0.5%? Tell me. Option number 4 is correct, sir. Very good. Option number 4. Kanishka, I can see that you have retracted one message. Try not to do this in exam, okay? But if you try to do this in exam, you can't just untake any problem, okay? So if you have answered something wrong, that is your final answer, okay? Try not to retract the message. So you have next time you have answered option number D, okay? Good. Let's see if the option number D is answered or not. No. Okay. 0.5% weight of carbon, it means how much? What is it? 0.5 is how much? 0.5 by 100 of X. It means of is how much? Cross the value of whatever the molecular weight is, right? Of the compound. That is equal to 78.4, right? Then what is the answer? 7840, okay? Because I multiplied 100, then I divide by 1, 2, so I have to multiply it by 2, okay? 7840 into 2. Let's see. 7840 into 2. 7840. What is the value of 7840 into 2? 7840 into 2. 15 something, 15680. So the answer is 15680. Which one of them is the answer 15680? I think this right, because if I put this, so 1.568, this should be the answer. Okay. So our option number, wait. Oh no, this is 10 to the power 3. This is 10 to the power 4, right? This is the option 1.568 in 10 to the power 4. So this is our answer, right? I hope everybody got it right. Let's go to chats. Okay. Now, one of my friend is also here. Okay. Okay, now this is the third question. Try to do it. Oh, I don't want a stopwatch, I want a timer. Okay, 1 minute. Try to understand the question. Option number 3, I'll get out of the frame. When 22.4 liter of hydrogen is mixed, okay, with 11.2 liter of Cl2, and both are at STP, the moles of HCl formed is equal to how much? Tell me. Tell me what is the answer. The timer has started, 30 seconds are left. Okay, 23 seconds. This one is an easy problem, okay. Tell me, Kanishka, Priya, Abdul, anybody? I'll just call more people. Okay. Okay, now let's start doing the questions. So, when 22.4 liter of hydrogen is mixed with this much amount of chlorine, it is asking how many moles of HCl is formed. So, can you tell me the chemical equation between hydrogen, chlorine and HCl? Tell me. Okay. So, Priya is saying 1, Kanishka is saying 2. Okay. Let's see what is the right answer. So, the equation is this. H2 plus Cl2 is equal to 2HCl, right? I hope the equation is balanced, right? Now, when you add H2 with Cl2, you will obtain 2 molecules of HCl, okay? Remember, what is the stoichiometric ratio? Ratio 1 and ratio 2. It means, if you use 1 liter of hydrogen, 1 liter of chlorine, you will get 2 liters of HCl. Got it? 1 liter of hydrogen, 1 liter of chlorine, then 2 liters of HCl. Now, see, 22.4 liter and this is 11.2 liter. It is how much? 22.4 and this is how much? 11.2. Now, the question is, hydrogen and chlorine are combining in the same ratio, but they are not present in the same ratio. So, this 11.2 liter, okay, it will combine with the 11.2 liter of the chlorine to form how much amount of HCl? 22.4, okay, 22.4 liters it will form, and this will be left as it is. This amount of hydrogen will be left as it is, okay. So, at the end of the reaction we have H2 11.2 liter and 22.4 liter of what? HCl, got it. So, let's see what is the answer. Okay, 22.4 liter is how much? 22.4 liter of any gas at STP is equal to 22.4 liter of any gas at STP is equal to 1 mole. Okay, so 1 mole of HCl gas. Okay, we'll have 1 mole of HCl gas. I hope. So, Priya Jyoti, you are right. Okay, Kanishka, you got little wrong this time, but don't worry, start solving the question again. Now, do the next question. Okay, so let's start doing the next question. Let me set a timer. Where is timer here? This question. Okay, I hope you can see the full question, right? Question number 4. Start. Okay, an element X has the following isotopic composition. This is the isotopic composition. Okay, sum to 200, 190 and 202. What is the weighted average? Okay, find a weighted average. Okay, good evening, Karthi. Good evening. Start solving the questions. Okay. Let me just call more people from here. Okay. Okay, 3 people are there. Solve this question quickly. 23 seconds are left. Okay. So 4 seconds, 3, 2, 1. Okay, time's up. Now let's see what is the question. Question number 4. I think it's option 4, sir. I think it's option number 4. Let's see if it's option number 4 or not. Okay. So Priya has answered option number 4. Question number 4. An element X has the following isotopic composition. Okay. So 90% is this element, 8% is this element, 2% is this element. Okay. See, I will tell you how to calculate option number 2. Okay. Priya is saying option number 4. Kanishka is saying option number 2. Let's see who's right. Okay. Now, whenever you want to find a molecular weighted average of different isotopic compounds, okay, so you have different isotopic compounds for the same element. Okay. So here is same element and same element. This element weighs 200, this element weighs 199, okay, and this element weighs 202, right? Now, the weighted average of this all of these compounds, okay, is going to depend upon their composition. So what is the composition of this? This is 90%, okay. I am going to write everything in ratio, okay. Now it will be a weighted average. We are doing weighted average, simple. Whatever the concentration multiplied by the weight, concentration, weight, concentration into weight. Now the concentration I am going to write 90% in ratio. So 90% in ratio is 0.90, okay, and this is 0.08, okay, and again this is 0.02. Now multiply these numbers, multiply this number with this one by this one by this. So this is M1 X1, M2 X2, M3 X3, okay. If you multiply M1 by X1, M2 by X2, M3 by X3 and add them all, you will get answer, okay. Hi sir, Aishu A. Hello, how are you? Now let's calculate, okay. I am going to use calculator, but you should not use calculator, make sure, keep it in mind. Now 200 into 0.90, okay. Now it is 180, again 199 into 0.08, okay, so 15.92, okay. Now this 0.02 into 202, so 0.02 into 202, okay, that is 4.04. Now we just add all these numbers to get what is the weighted average, okay. So 4.04, 15.92 plus 180. Our answer is 199.96. Our answer is 199.96, which is closest to this answer. So option number 4. Let's see who was right. Let me shout out their name. Sure, option number 4 is correct answer. Yes, Priya Jyoti, you are right, and Aishu, you are also right, and somebody else, Priya Jyoti already answered. Kanishka, try not to retract your answer. Okay, you are retracting answer like much often. Okay, next question. Question number 5th. Okay, timer has started. Now whenever the questions are easy, okay, I'll just start the timer right away. Start doing, Priya, Aishu, Karthi, okay. Start doing the questions. If there is any lag in the audio or in like video, you just let me know in the comment section, okay. Oh sorry, live chat. 35 seconds left. Try to do it quick. You just have to find the ratio of the number of atoms in this much of carbon dioxide, okay, and this much of 1.7 gram of ammonia, okay. Let's see who has got some answer. Quickly, if you are in exam, okay, try to do this answer in like 30 seconds, okay. This is not that much amount of, it's not a tough question, okay. So 3, 2, 1. Okay, time's up. Now let's see what is the answer. So this question is quite simple. It is asking us what is the ratio of the number of atoms in 2.2 gram of CO2. So 2.2 gram of CO2 and divided by the 1.7 gram of ammonia. Okay, so we have to find the number of atoms. Okay, whatever the number of atoms ratio is, same will be the ratio of the moles. Okay, because same number of moles contain same number of molecules. So if we want to find out the ratio of number of atoms, it is as same as finding the ratio of moles. Okay, because 1 mole always consisted of definite number of atoms. Okay, got it? Now 2.2 gram of carbon dioxide. What is the molecular mass of carbon dioxide? It is 44. Okay, so 2.2 divided by 44. Now what is the molecular mass of this ammonia? Sir, nitrogen is 14, H3 is 3, so 3 plus 14 is how much? 17. So now this is 1.7 divided by 17. I think it is somewhat 1 by 10, right? And this thing is how much? 2.2 divided by 4, that is around, if I just write it as 10, this is, okay, 1 by 20, huh? That is 1 by 20, so 10 will go on upside, so 10 by 20, okay. Now let's see which answer is 10 by 20, oh sorry, 1 by 2. So yeah, option number 1. Let's see who has answered. Kanisha has answered option number 3, Priya has answered option number 3, okay. Let's see if, okay, Alok Verma, okay, hi. I think I've heard this name. Is option number 3 right answer? Am I doing something wrong? No, I don't think so. Because, okay, 2.2 gram of carbon dioxide is divided by 44, that is 1 by 20, okay, 1.7 gram, okay. No, I am not doing something wrong, okay, the answer is this 1 by 2, correct? So, I think this time nobody was right, but okay, next time try to do it. Next question. And let's set a timer, okay, sometimes you get extra 2 or 3 seconds, okay. I'll start this out. 3, 2, 1. What is the mass of carbon dioxide that shall be obtained by heating 10 kg of 80% pure limestone calcium carbonate? Okay. Alok Verma, hi. Hello, Alok Verma. I am just a single person right now in the studio. Okay. So I can't just manage every chat and all those things. Okay, like 5 people are watching. Okay, 23 seconds are left. The limestone is 80% pure, okay, remember. So that 20% of the total limestone is actually just dirt, it's not real limestone, remember this thing. Let's try to do this problem. Okay, so the mass of carbon dioxide that shall be obtained heating 10 kg of this particular limestone. Okay, so when you heat limestone, what is the chemical reaction for heating limestone? I hope it is pretty popular. Okay, everybody knows this reaction. Okay, okay, CO2. Now calcium carbonate, if you heat it, it will break down to calcium oxide and carbon dioxide. Now can you tell me what is the mass of this thing? Okay, by the way, let's balance the equation. 2 and 3 oxygen atom, 3 oxygen atom, C1, C1, calcium 1, calcium 1. Okay, now this equation is already balanced. Let's see if somebody's got the answer. Sam, hi. Hi Sam. Okay, Priya Jyoti has answered option number 3. Let's see option number 3 is right answer or not. Okay, so this thing is 80% pure. Now we have 10 kg of this thing, so 1 mole of this will produce 1 mole of this and 1 mole of this. Okay, now how many moles of calcium carbon dioxide calcium carbonate we have? How can you find? So 10 kg. Okay, so we have 10 kg. Now what is the value of 10 kg? It is 10,000 grams. Okay, got it? But remember, not all of this 10,000 gram is calcium carbonate, only 80%. So I am going to multiply it with 0.80. Okay, to represent 80%. So it means 80% of this total 10 kg is calcium carbonate. It means 80 kg only. It means 8,000 gram. Okay. And calcium carbonate, I hope the mass is, this one is 40, 12 and add, I think it's 100, right? Okay. Alok Verma is answering 3.52 kg. Option number 3, sir. Let's see. So 8,000 divided by 100. Okay. Cancel, 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 cancel. So 80 is the moles. Okay. If 80 moles of calcium carbonate has been burned, okay, then we are going to get 80 moles of this carbon dioxide. Okay. So 80 moles of carbon dioxide into 44. Why? See, you got 80 moles, right? And 1 mole of carbon dioxide weighs 44 gram. Okay. So this will be the right answer. So 80 into 44. Let's see. 80 into 44. We have 3520 grams. It means 3.52 kg. Okay. So whoever wrote the answer option number 3, let me take the name. Aishu, you are right. Kanishka, you are right. Alok Verma, you are right. Okay. And Sujit, welcome. Okay. Priya Jyoti, you already wrote answer number 3. You are right. Okay. Well, okay. Very good. Very good. Everybody is just answering. Okay. Now, I'll take the name of those people who have answered in top 2 or top 3. Okay. Let's see who's able to do this fast. Now, this is question number 7 in front of you. I'm starting the timer. Timer is started. Whoever is going to answer fastly, I'm going to take it. Okay. Identify the incorrect statement among the following. Okay. So we have to identify incorrect statement. Tell me what is the answer. Incorrect statement. Incorrect statement. Tell me. Okay, 25. Okay, 25 seconds. Let's see if somebody has answered or not. And by the way, just remember there is a 1 minute lag. Okay, so if you answer right now, I might. Okay, the video you are seeing right now, it will reach to you after I say it after 1 minute. Okay, but the chat is totally live. Okay, time's up. You put your answers. Let's see who is able to do everything. Mark. It is asking us identify the incorrect statement. Okay, now see. 1 mole of N3 negative. Remember it is 3 negative. Okay, ions have 10 mole of electrons. How can we say 10 moles of electron? Can we say that? Think about this. What is total number of nitrogen? In 1 mole of nitrogen, ions have 10 moles of electrons. Identify the incorrect statement. Okay. So N is having 7 electrons. Okay. So N3 negative will have 10 electrons. Okay. Right. So for 1 particle of nitrite, it is having 10 electrons. Then what does it mean? It means 1 mole of this thing is equal to 10 moles of the electrons. So 1 mole of this is 10 moles of electron. Very good. You are right. Oh, sorry. This is not the answer. We have to find the incorrect statement. So this is correct. Now, option number 2. 1 mole of O2 negative ions have this much number of electrons. Okay. This is the number of particles. Sir, option number 2. Okay. So who has answered first? Kanishka, this time you again retracted the message. Try not to do it. Be wrong. It's not a problem. Okay. You can be wrong, but don't try to just inculcate yourself into thinking that you are right. Okay. But anyways, best try. Priya Jyoti, you have answered first. Option number 2. Kanishka, option number 2. Aishu, option number 2. Let's see. Everybody is saying option number 2 is option number 2, the right answer. So 1 mole of O2 negative ions have this much amount of electrons. So should I convert this into moles? Right? I should convert this. So this much amount of number of particles. How to convert into moles? Given particles upon number of particles. Sorry, Na. Right? This is the moles. Given number of particles upon Na. So what is the given number of particles? This is. Okay. Divided by what? Na. What is the value of Na? This is the value of Na. Sorry, 23. Okay. This cancel is equal to 1 by 10. 1 by 10 is 0.1 and that is not correct. That is it's really not correct. O2 negatives. Okay. Remember it has 8 electrons in its shell. Okay. And if you add 2 electrons, it is 10 electrons. So it should be 10 moles. It should be 24 over here. Then we will get 10 moles. So this is wrong. It means this is the right option because we have been asked to identify the incorrect statement. Got it? Now, I issue option number 2. Okay, I issue you are right. I think I read it again. Now, let's go to the next question. Okay, this is next page. Option number 8. Okay, question number 8. Let's start the timer. Try to answer it quickly, okay, and try to do questions verbally. Okay, Kanishka, Priya Jyoti, Aishu, okay, everybody, just try to do the question. I'll just get side, okay. I just thank everybody who's joined. Class is going on. Whoever is left, join. And by the way, if you have any other doubts and all those things, try to just ask me. We are not just doing DPP. If you have some doubts, you just let me know. Okay, I'll clear it. 20 seconds left. Okay, I don't think this question will take that much time. Okay, let's start. I should watch the chat also. Calculator. Okay, not yet. Let's read the question. So, the number of water molecules is maximum in, so it is just asking us in which of the option the number of water molecules is maximum. 18 molecules of water, so how many molecules of water? 18. Okay, got it. Here, 1.8 gram of water, 18 gram of water, 18 moles of water. See, 1.8 gram of water is how many moles? Given mass upon molar mass, right? That is 0.1 moles, right? Now, 18 gram of water is how much? 18 by 18, that is 1 mole of water, okay? And 18 moles of water is how much? 18 moles itself. So, this is very less, 18 moles. This is 0.1 mole, okay? This is 1 mole, this is 18 moles. So, obviously, 18 moles, it means it will have this much number of particles, so it is very high. So, option number 4 is the right answer. So, Priya Jyoti has answered option number 4, Kanishka has answered option number 4, okay? Option number 4 is the right answer. Now, let's go to the option number, okay, question number 9. This question can be just a little bit tricky, okay, but I think you guys can solve it. Try to read the question carefully, okay? I'll give it for a great time for this question, okay? Set it to be 0 and I'll keep it 1 minute and 30 seconds, I guess, is enough, okay? It's not a tough question, just a little, mind-boggling question, okay? Sir, what is DPP? Daily practice problems, okay? Abdul, you have asked what is DPP, it is called daily practice problems. So, we are just giving you problems daily to practice it, okay? Try to do it. 57. Question number 9. Let's see who is able to do this question first. Last time Priya and Kanishka has answered it. Okay. The formula of acid is this. The mass of this much amount of moles of acid is this. Okay. So, if you take this much moles of acid, this is the mass. Okay. Then what is the atomic weight of X? You know the atomic weight of hydrogen and oxygen. You can get the atomic weight of X if you know the atomic weight of whole of this thing. Thanks, sir. Good. Not a problem. Okay. 15 seconds. 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Done. Okay. Now, let's try doing this problem, okay. See, it is asking us the atomic weight of X. So, it is asking the atomic weight of X. If I know the weight of whole of this thing and I subtract the weight of hydrogen and I subtract the weight of 2 atoms of oxygen, then I will get the weight of this X. So, the question is, what is the atomic weight of HXO2? Okay. What is this, atomic weight, molecular weight I will say, okay. So 0.0242, okay, moles to 0.0242, okay, 0.02 moles, okay, is equal to 1.657 gram. Got it? So this much mole is equal to this much gram, okay, 68.47. Somebody has answered 68.47 is not the right answer, okay, but Priya Jyoti, you have answered option number 1 and then you have written 68.47. I am expecting the option number 1 is what you are saying. So if this much is this much gram, then 1 mole is equal to how much? You divide this number, so it is 1.657 divided by 0.0242. Got it? Now let's divide it and get our, not the answer, okay, we'll just get the weight of this particular thing. So 1.657 divided by 0.0242, okay, so 68.4, okay, very good, okay, so 68.47 was the weight of HXO2, okay, this was being told by Priya, okay, I thought she is answering the question, okay, 68.47, and when you subtract the mass of 2 oxygen atoms, okay, that is 32, right, 16 to 32 and then 1, that is 33, okay. So if you subtract 33 from this, so we got 3 and then 35.47, okay, and 35.47 is equal to 35.5. Simple. We got the weight of this to be 68.5 nearly, and we subtract the mass of hydrogen and 2 oxygens, we got 35.5. Got it? Okay, sir, that's for HXO2. Yes, yes, I got it. Okay, I got it. Okay. Okay, try to write the whole explanation because the video is lacking just 1 minute. We'll get it done. Okay, 32 plus 1. Okay, good, good, good. Now let's do this question. Timer. Okay, start. So 100 milliliter of H2SO4 solution having molarity of this much and density of 1.5 gram per liter is mixed with this much water. The molarity of H2SO4 solution will be. Okay, I'll give some, okay, some greater time for this. Not much, but maybe like, okay, 1 minute 15 seconds is enough, okay. 35.47, yeah Priya, 35.47 and 35.5 are near, okay, so we'll just answer it. Okay, timer is there, 1 minute. We have to find a molarity and simply dilution is happening, okay, 400 milliliter of water you are adding, okay. So at the end you just need to know total number of moles divided by total number of volumes, that's it. Okay, I'll open here. Okay, I can see myself now. Yeah, good. Okay, Priya, try to answer it. Abdul, try to answer it. Only 25 seconds left. Do we have water over here? Okay, 8 seconds, 7. Okay, Kanishka has answered for the first time. Okay, so Kanishka has answered option number 4. Let's see who's right. Okay, 0.227. I think you're right. Now, okay, done. Okay, so 100 milliliter of this particular thing is having 1 molarity. Okay, let's write the information. At the end, we want the molarity of H2SO4 solution. Okay. So what is molarity? Total number of moles divided by total volume. So first of all, when you are diluting the solution, is the number of H2SO4 moles going to change? Yes or no? No, they are not going to change. So initially you have X number of moles, finally you will still have X number of moles. Okay, so 100 milliliter into 1 molarity, it means 100 milliliter into 1, okay, volume into molarity is equal to the number of moles. Okay, so that is 100 into 1 and that is in milliliter. Okay, so you convert into liters, that is 0.1 into 1, that is 0.1 moles. So 0.1 moles of H2SO4 is there in the solution. Now the question is, we have added 400 milliliter. Okay, so initially we had some volume and we added 400 milliliter. Okay, make sure to convert this into liters, don't forget this. Okay, now how to get the initial volume of the solution? Is there anything given? Yes, option number 4, Aishu option number 4. Okay, but this time Kanishka is first and Aishu is second, Priya third. Now 1.5 gram per milliliter. So it means this much gram per milliliter. Okay. So let's calculate how much weight. Okay. So we already have 100 milliliter. Why are you doing this? Wait. 1.5 gram per milliliter. Okay. With 400 milliliter of water. Molarity of H2SO4. Final density is 1.25 gram per milliliter. Is I doing something wrong? 100 milliliter of H2SO4 solution is having. Wait, I am confused itself. Okay. Option number 4. 100 milliliter of H2SO4 solution having molarity of 1 molality and density is 1.5 gram per meter is mixed with 400 milliliter of water. Okay, the molarity of the H2SO4 solution will be. Okay. So see. Wait. So initially 100 milliliter of H2SO4 solution is there with the molarity is 1 mole. Okay, so 100 milliliter solution, it means 0.1 mole. Okay, sorry, 0.1 liter into what is the molarity? 1 molarity. Okay, so what is the answer? That is 0.1 moles are there. Okay, now 0.1 moles are there and the final density is 1.25 gram per milliliter. Can you tell me what is the mass of H2SO4? 2 hydrogen. Okay, plus 32 plus 16 for 64, right? So that is around 98. So if you multiply it, so that will be 98 gram for 1 molecule for 0.1 moles, sorry, 98 for 1 moles, for 0.1 moles it is 0.1 multiply. Okay, so 9.8, right? Okay, now we have 9.8 gram, got it? Okay, 9.8 gram, 9.8 gram is the answer, no. And we have given with the final volume, the final density is 1.25 gram per milliliter. Okay, so we have the weight, we can find out the volume from there, then molarity we can find easily. Let's see. So 1.25 is the gram per milliliter. Okay, so mole upon mass upon volume is equal to density. Okay, so density is 1.25, final density is 1.25, right? So if you want the volume, so mass divided by 1.25. Okay, mass divided by 1.25. So mass is 9.8 divided by 1.25. Mass divided by 9.8 divided by 1.25. Okay, 7.84. Wait, am I getting something wrong? Wait. This is okay. Okay. Wait, 0.2 to 7. I'm just. Okay. Initially we had how much? 0.1 moles, simple. Okay, initially we had 0.1 moles, 100 milliliter, okay, plus 400 milliliter, okay, it means how much? 500 milliliter. Okay, 500 milliliter is how much? Tell me, what is the value of 500 milliliter? That is half moles, right? And if you multiply this, you will get 0.2. Okay, now I do not know why this particular options are given, why this thing is given. Okay, you can calculate it. And near the answer is this, option number 4. Okay, I got a little confused. You can fast forward the video, okay, for this. Now let's go on to the next problem. Okay, let's start this problem. Timer. Okay, 150 plus 400. Okay, Priya Jyoti, one message retracted. Where should I put it? Now it is correct. Okay. The maximum number of water molecules among the following is, so we just need maximum number of water molecules. It's easy. It won't take that much. 550 divided by 1.25. There is something wrong in the previous question. Okay. I might be just getting confused. 16, 15, 14. 12, 11, 10, 9, 8, 7, 6. Priya answer this question. Kanishka, Aishu. How many people are there? Okay. Okay, let's calculate. Now, the maximum number of water molecules among the following is, we just need to calculate maximum number of molecules, or you either calculate maximum number of moles, the answer is going to be same. Okay. 18 milliliter of water. See, 18 milliliter of water. Okay, you have to divide it by 22.4 liter. It means 22,400 milliliter. So this is the number of moles in option number 1. Option number 2, 0.18 gram of water. What is 0.18 gram of water? If you divide 0.18 gram by 18 gram, you will get the number of moles, that is 0.01. Okay, right? I think 1. Aishu is saying option number 1. Priyajyoti is saying option number 1. Okay. Now 0.00224 liter of water vapors at 1 atm and 273 Kelvin. Okay, so it is like standard condition of temperature and pressure. That's it, nothing else. Okay, so 0.00224 liter. Okay, 0.00224 liter. Okay, 0.00224 liter divided by 22.4. Okay, and 10 to the power minus 3 mole of, okay, 0.001. Sorry, 0.1. Definitely, see, this number is smaller. This number is 0.01 moles. Okay, so it is larger than this. So you cancel this option. Okay, then we have 0.01 mole. Maximum it's asking. So now this is 0.01 mole and 18 milliliter of water. Okay, so this will be, I think this is the right option. Option number 1 is right. Wait, let me check. 18 divided by 22,400. Okay, I think, wait, 10 to the power minus 3 milliliter. The maximum number of water molecules among the following is so 18 milliliter of water. Okay, so we divide 18 divided by 22.4 into 4. Okay, wait. Doing something wrong over here. Okay, 18 milliliter. Okay, it was not given at STP. Okay, this thing is not given at STP. It means 18 milliliter is 18 gram. Okay, 18 gram divided by 18 is 1 mole. Okay, so that's why option number 1 is right. Got it? I hope everybody gets it. Okay, until unless things are given at STP, don't assume them at STP. Okay, I just assumed that this thing is at STP. That's why my answer was coming out to be wrong. Okay, now let's forward to the next question. Okay, by the way, Priya Jyoti first, Kanishka second, Aishu third. How many electrons are present? Tell me. How many electrons are present in 3.2 gram of sulfide ion? It's sulfide. Sulfide, it means S2 negative. Okay, it's S2 negative. Sulfide ion S2 negative. Tell me quickly, Priya, Kanishka, any other person is there? How many electrons are there present in 3.2 gram of sulfide ion? You just need to know what is sulfide ion. Okay, it's S2 negative. Okay, tell me. It depends upon, okay, 3.2 gram is there. What is the mass of sulfur? Tell me, what is the mass of sulfur? Sorry, atomic number. Okay, so mass is 32 gram, given is 3.2 gram, this much is the number of moles. Okay, timer is set, right? It will end. Okay, so we have 0.1 moles of sulfide. Okay, sulfide ion. Now let's see how many electrons are present in sulfide. Sulfide is S2 negative. It means we have to calculate the total number of electrons. How many electrons are present in this? It means, see, it is 16. Okay, 2 extra electrons, so it will be 18. Right? Total number of electrons is 16. I hope I am right. Okay. So option number 2, sir. Okay, let's see, 18 into 0.1 moles. Okay, so we have 18. It means 18 moles. Okay, in 0.1 moles. Sorry. 1 mole of S2 negative is having 18 moles of electrons. So 0.1 mole is having 1.8 moles. Got it? Now 1.8 moles of electron is how much into Na? How much is the value? 1.8 into Na. What is the value? Let's just calculate it. 1.8 into 6.022. Okay, 10.83 and wait. Option number 2, 20.8. 20.8 into 10 to the power 23. Wait, how many electrons are present in 3.2 gram of sulfide? Wait, okay, wait, do it. Okay, sorry, it's okay. In the outer side there is 8, and when you add it's 2. Sorry. When you add it's 2, then it is 10. Okay, so 1 mole is 10 moles of electrons. So 0.1 mole is how much? 0.1 mole is how much? it is 1 mole. Got it? No, that's not the answer. I think 1, sir, 2, sir, 2, sir. Okay. Option number 2, 20.8. Wait, 20.8. Let's see if your answer is right or not. Okay. No, I guess. No, this option number A. I think this option number A. Wait, total electrons is 18. 18 into how much? 18. Okay. So 18. And for 0.1 mole it will be 1.8 and 1.8 into 6.022. Okay, that is okay, 10.8. Okay, I was right. You guys are answering wrong. I thought I am wrong. 10.8 into 10 to power 23. Okay, got it? So option number 1 is the right answer. Check your answers. Okay, Aishu, you are right. Okay, but then you wrote 2. Why? It's 10.8. Not 20.8. Okay, let's do next question. Total number of protons in 10 gram of calcium carbonate. Just calculate total number of protons. Okay, it's not a big deal, so I'll just, okay, 1 minute is enough for this question. Aishu, everybody just check. Total number of protons in 10 gram of calcium carbonate. Sir, can you explain it again? Wait, question number 12. Sir, can you explain it again? Wait, I'll just explain it once again. How many electrons are present in 3.2 gram of sulfide ion? Okay, first of all, you have somebody doesn't get this particular question. Question number 12. 3.2 gram. Okay, we have sulfide ion. Remember. Wait, it is sulfide, right? So in the 3.2 gram, why I was dividing with 32 gram? Oh, you got it right. So total is how much electrons? 16 is atomic number, 2. Okay, you add it, you are getting it as 18. Okay, so you have 18 as the number of electrons in one sulfur atom. Okay, so we are dividing it with, oh wait. So we are dividing with 32. See, one sulfide ion. Okay, so whatever the mass is, we divided it by the molecular weight. We got how much? 0.1 moles. Okay, remember, this is given moles. Okay, now remember, in 1 mole of sulfide ion, there are 18 electrons. So 1 mole of S2 negative will have 18 moles of electrons, right? So 0.1 mole of S2 negative will have 1.8 moles of electrons, right? I hope you are able to understand, right, Priya? And then we just have to calculate how many electrons are there in 1.8 moles of electron. So 1.8 into moles, it is how much? 6.022 into 10 to the power 23. You multiply this with this, you will get this. Okay, and you can see this 1.8 into 6.022. Sorry, 1.8 is 6.022. 10.83. Okay. So 10.83 into 10 to the power 23. So the option number 1. First you find out how many number of moles are there in 1 mole of sulfide. So for 0.1 mole of sulfide, you have 1.8 mole of electron, and 1.8 mole of electron has this much number of atoms. Okay, sorry, particles I'll say. Okay, let's go to the next question. You just have given a look to this question. Okay, so I'll directly start solving because I have already given you the time. Okay, either way I'll wait for the, okay. Yes sir, got it, thank you. Okay, got it. Now question number 3, total number of protons in 10 gram of calcium carbonate. Calcium, okay, so calcium carbonate. Okay, got it. Now calcium has how many number of protons are there in calcium? So 20. Got it. How many number of protons are there in carbon? Tell me. Oxygen we have 8, so 8 is 24. Carbon we have 6, so 24 plus 6 plus 20 is how much? 50 protons in 1 mole, sorry, 15 protons in 1 molecule of calcium carbonate. Okay, so it means the mole ratio is how much? So 1 calcium carbonate is equal to 50 proton moles. Okay, 50 proton moles. So how many moles are there in 10 gram? What is the mass of calcium carbonate? Sir, 100 gram. 100 gram is the molecular weight. So given mass 10 gram upon molecular weight is the number of moles of calcium carbonate. Okay, so that is 0.1 gram, sorry, not 0.1 moles. Okay, and 1 mole is equal to 50 proton moles. So it means 0.1 mole is equal to this much amount of moles of proton. Okay, so that is 0.1 into 50, this 5 moles. Okay, so 5 moles of proton, and 5 mole of proton is this asking number. Okay, so 5 moles is equal to 6.022 into 10 to the power 23. So it is 5 into something, that is 30. So 3 into 10 to the power 24 should be the answer somewhere. Okay, 3 into 10 to the power 24, 3 into 10 to the power 24, 3 into 10 to the power 24. This is option number 1. Let's see who's given right answer. So okay, somebody new is there. Okay, I don't know, MXXNSTXXXCK1635. Okay, you comment down your name because I am not able to take your name. Option number 1, he has given the right answer. Then Kanishka, okay, then Priya Jyoti. So you guys are right. Got it? This time everybody was right. Let's see for the next question. Okay, start. Number of hydrogen atom in 1.7 gram of this much is, it's very easy. Let me just tell everybody that I am in here. Okay, 33 seconds. Number of hydrogen atom you have to find in 1.7 gram of ammonia. Let's see who is able to answer first. Okay, and whenever you are writing answers, try to write it with the question number. Okay, which question number we are talking about, because there is a lag of 1 minute. Okay, 4, 3, 2, 1. Okay, number of hydrogen atom in 1.7 gram of ammonia. Hey, not timer, I want marking. So 1.7 gram of ammonia. What is the mass of ammonia? First of all, tell me. Sir, nitrogen is 14 and 3, that is 14 plus 3 is 17. Okay, 3 hydrogen atoms, 3 mass, 1 nitrogen, 14. So that is total 17. 1.7 gram is how much? Given mass upon molar mass is equal to the number of moles, and that is 0.1 moles. Okay, so it is asking a number of hydrogen atom. See, it is 0.1 mole. Okay, this whole thing is 0.1 moles, but in this there are 3 hydrogen atoms. So if we take 1 mole of ammonia, it is equal to 3 mole of hydrogen in there, right? Because of 3 atoms, so there will be 3 times more hydrogen atom. So 0.1 mole of ammonia is equal to 0.3 moles of hydrogen. Okay, 0.3, because there are 3 hydrogen atoms in one atom, in one compound. Okay, so 0.3 moles. Now 0.3 mole, how can you get number of moles? Just multiply it with Na. Okay, they have already given an answer. So Priya Jyoti have answered option number 1. Why? We are asking number of hydrogen atom na. So if you get 1 molecule of this, you will have 3 molecule of hydrogen. 1 mole of this, 3 moles of hydrogen. 0.1 mole of this, 0.3 moles of hydrogen. Okay, so 0.3 into Na number of molecules are there. Try to get your answer corrected. Okay, is my chat not loading? Okay, option number 1 everybody is given. Okay, let's go on to the next question. Okay, try to do this question. Sir, I didn't answer this question. Okay, sorry. I got it. Oh, that was previous question. Okay, that's why I'm not able to identify which question you are answering. Option 1 is previous one, sir. Okay, yeah, I got it. Okay, try to answer this question. Oh, I have not set the timer, sorry. Okay, I will turn this timer off after, if 10 seconds are left, because I gave you 10 seconds extra. the maximum number of atoms is present in which of the following? Tell me. 1 gram of Mg, 1 gram of this, 1 gram of this, 1 gram of this. Okay. This answer is quite easy. I will not give you that much time. It's very easy. See, what is the maximum number of atoms? Okay, it is asking. It means maximum amount of moles. So you need to know which is giving more amount of moles. Okay. So more amount of moles, more amount of particle. Now see, 1 gram of Mg, 1 gram of oxygen, 1 gram of Li, 1 gram of Ag. What is moles? Formula for moles. It's not a tough question. Formula for moles is given mass, okay, upon molar mass, right? That is the formula. That is the formula for moles. Okay. Nobody has answered this question. Okay. Option number 4. Priya Jyoti, you have answered option number 4. Option number 4 is not right answer. See, given mass for all of these things, 1 gram, 1 gram, 1 gram, 1 gram. So everybody is having 1 gram. So it is going to be divided by their molecular weight, Mg, molecular weight O2, molecular weight lithium, molecular weight Ag. Okay. It is going to be divided by some number to get the number of moles. Okay. Okay. It is asking maximum number of moles. Oh, Mg is having some mass, O2 is having some mass, lithium and Ag. See, which one is having the least amount of molecular weight? I think lithium. See, I think Priya, you are answering something wrong. It is asking maximum number of atoms. So for the atom to be maximum, okay, for the same amount of mass, this number should be minimum, right? Your molecular weight, if it's minimum, so you divide 1 gram by the mass of Mg, 1 gram by mass of O2, 1 gram by mass of lithium, 1 gram by mass of Ag. Then the least one will be the lithium. Okay. Why? Because whatever the mass of lithium is, it's 7, right? So 1 by 7 is the highest number among this. It is 1 by 32. Got it? It is 1 by 7. Same weight will have some mass. Same weight will have some mass. But this number, because the denominator is least, the numerator is the highest. So highest number of moles. Okay. So highest number of particles. That's it. So this was option number 3. Everybody got it wrong? Kanishka, you got it wrong. I saw you answered 4. Okay, now you have retracted the message. I can see who has retracted the message. It's written over here. Okay. So try not to retract the message. If you are wrong, you are wrong. So this time nobody is right. Not Priya, not Kanishka. Okay. Read and do this question. The number of moles present in 2.5 liters of 0.2 mole H2SO4 is how much? It's very easy. I will not give you just 30 seconds for this question. I'll just give you 30 seconds. If there is any confusion, okay, you let me know. Let's see how many people are watching this stream. Okay, option number 3. Let's see how much. Okay, very easy. The number of moles are present in 0.25 into, it's very easy. Molarity is equal to, you should not even wait for this question. Molarity is equal to number of moles per unit volume. Okay, right? So number of moles is what we have to find. So number of moles is equal to molarity into volume. What is molarity? 0.2. What is the mole? Volume? 2.5 liters. Okay. 2.5 into 0.2, it means 1 by 5 into 2.5, that is 0.5. So 0.5 is option number 2. Okay, check the number of moles present in 2.5 into 0.2. So 2.5 into 0.2. Sometimes I am checking very silly problems. Okay, 2.5 into 0.2, that is 0.5 is the answer. Let's see who has answered right. Sir 2, Kanishka, message retracted again. Option number 2. Okay, Nandane Priya. Okay, Priya, welcome to the stream. Okay, start answering the question. So option number 2 is right. Let's go to next question. Okay, try to do this question. 16, option number 2, very good. Okay, try to write the question number also. Okay. The number of valence electrons present in 0.53 grams of this. Okay, so it's a molecule. So it has sodium, carbon and oxygen, and every one of them is having different number of valence shell electrons. Okay, got it? So you have to add total number of valence shell electrons in the whole compound, and then you can get it. "22 seconds are left. 16, okay, 17 question number, guys, answer. Okay, let's see, nobody has answered till now. 17, option number 3. Let's see if your option is right or not. Okay, so number of valence shell electrons in 0.53 gram. I do not know 0.53 gram or whatever. Okay, so Na2CO3. So Na2C and O3. It means 3 times of O. So sodium is having 1 valence shell electron. So total number of valence shell electrons 2. Carbon is having how many number of valence shell electrons? 4. Okay, and oxygen. What is the amount of valence shell electron in oxygen? 17. Somebody has answered. Okay, wait. 17 is option number 3. Option 3 for question number 17, sir. Nandini has option number 2. Kanishka is saying option number 1. Okay, somebody is 1, somebody is 2, somebody is 3. Okay, now 2 and 6, right? So if you see for oxygen, it is 6, right? 3 into 6, that is 18. So okay, so valence shell electrons in oxygen is, yeah, it's 8, right? Okay, yeah, 8. 2, 8, and okay, 2 is 6, yeah. 6, 3, 18, 18, 19, 20. So it's 18 plus 6, how much? 24. Okay, so total number of valence electrons, okay, in, what was the answer? Okay, 24. I have written 24. Now in one molecule of this is 24 valence shell electrons are there. So now we have to calculate how many number of moles are there. Number of valence shell electrons present 0.53 grams. Okay, so we do not know the moles of this Na2CO3, but we know the mass. So 0.53 grams. Okay, given mass upon molar mass. What is the molar mass of this? Carbon is 12, oxygen is what? Oxygen is 16. 48 plus 12, 48 plus 12 is 50, 60, and 60 plus 23 into 2, 68 plus 23 into 2. So 2 into 23 plus 12 plus 63, 48, that is 106. Okay, total molecular weight is 106. Okay, and 0.53 gram divided by 106 gram. Now this is the number of moles. If I write it as 53 into divided by 106 into 100, okay, I took the decimal out, I got it 1 by 2, okay, that is 0.5 into divided by 100, that is 5 into 10 to the power minus 3. This much number of moles are there, okay, and in 1 mole there is 24 valence shell electrons. So 1 mole of Na2CO3, 24 moles of valence electrons. So this much amount we have to multiply with 24. So this is the number of moles in Na2CO3. We have to multiply it 24 times to get the number of valence electrons. So 24 into 5 into 10 to the power minus 3 moles. Okay, it is asking us the particles again. Okay, so 24 into 5 is how much? 24 into 5, 120. So 120 is into 10 to the power 3. Okay, so 120 is 1.2. Okay, 120 into 10 to the power 3, and again you have to do one thing. Wait, am I doing something wrong? Oh sorry, it's 10 to the power minus 3, it's not plus 3. Okay, that's why I was thinking if I multiply it with Na, I will have 10 to the power 26 answer. Okay, so multiply it 6.022 into 10 to the power 23. Got it? Now let's see. 10 power minus 3, 23 minus 3 is 20, and 20, okay, and I'll just write it here. Okay, so multiply it. If you multiply 23 minus 3 is 20, and 20 plus 1, 10 from here, okay? So that is 21, 10 to the power 21, and 12 into 6, it's 72, but I'll write it 7.2 and write it at 20 to the power 22, okay? So 7.2 something and 10 to the power 22, 7.2 something, 10 to the power 22. Option number 2 is the right answer. Let's see who has given the right option. So 1.20640, who's writing 1.20, okay. And sir Nandini Priya has said option number 2, and Priya Jyoti option 3 for option number 17. No, option number 3 is not the right answer. Option number 2 is the right answer, okay. Okay, so which of the following pairs have same number of atoms? Let's finish this quickly, okay. 16 gram of oxygen, 4 gram of water. Eighteenth, tell me. Tell me the answer. Only 30 seconds have been left, okay. I'll give just 40 seconds for this question. This is not that much of hard. Same number of atoms, okay. I think just is enough. This is not a great question, okay. So see, we just have to find the number of moles, and equal number of moles, equal number of particles, okay. Same number of atoms, okay. So same number of atoms, same number of moles, that's it. If the number of moles are same, our answer is right. 16 gram. So 16 gram divided by 32, okay, given mass by molar mass. Remember, I am doing given mass by molar mass. So 16 by 32 is half, and 4 gram by hydrogen, 4 given mass 4, molar mass is how much? 2. So 4 by 2 is 2. So this number is not same. No, this is not the answer. 16 gram of O2, that is 0.5 again. 44 gram of carbon dioxide, that is 1 gram. Sorry, 1 mole, okay. Given mass upon molar mass, okay. Given mass upon molar mass. Given mass upon molar mass, okay. Given mass upon molar mass. So this is 16 by 32, that is 0.5. But 28 by 28 is 1. Again not right. So this option, 12 gram of carbon. So 12 gram of carbon is 1 mole, and 23 gram of sodium is 1 mole. So this is the right option. Option number D. So who has given the right option? So Priya Jyoti has given the right answer, 18.4. Kanishka, again I saw you retracted the message. Your option was C. I just saw you retracting the message. And Aishu, option number 4. Okay. This time Priya and Aishu, you guys won. Okay. This question. Read this question. The timer is set here. 1 minute is the timing is running. 1 minute. Okay, Kanishka, 18.4 answer. Good, good. Number of moles into the number of molecules in 2 moles of ammonia is equal to the number of molecules in 4 moles of CH4. Is it right? I don't think so. And reason is both are chemically similar species. It's very easy question. 40 seconds is enough. It should not take you that much time. Okay, that's it. It should not take you that much time. Simple. It is asking number of molecules in 2 moles. Okay, it is going to confuse you with number of molecules. Always remember number of moles. Okay, number of molecules in 2 moles of ammonia. Okay, 2 moles of ammonia. Okay, 2 moles of ammonia is there, is equal to the number of molecules. Obviously, if number of moles are not equal, okay, the number of particles are not going to be equal. So assertion is wrong. Reason is saying both are chemically similar species. So reason is incorrect itself. Okay, they are not even chemically similar. One is a hydrocarbon, other one is not. So both A and R is wrong. Okay, so option A, number 4 is the right option. Let's see who has given this answer. Okay, 18, Kanishka 4, Priya 4, Aishu 4. Okay, 19. Somebody has read the, okay, 19. This question is 19. Okay, that's why I was asking you to write question number. So 19/4 Priya has answered right option. Kanishka, this time you have given right answer. I think which of the following has the greatest number of molecules? 20 seconds for this question. I am not going to give you much. 20 seconds, that's it. Okay. 20 seconds for this question only. Done. That's it. Sir, option C. Unnati Kishore, option number C. Okay. Write the problem number also. Okay. Because there is a 1 minute lag, I can't understand. So Unnati, write. Okay. It's enough. Now, which of the following has the greatest number of molecules? So greatest number of moles, greatest number of molecules. That's it. Okay. Now let's find the answer. 64 gram of SO2. Okay. What is the mass of 32 is the mass of sulfur, and 1632 again 32. Then total mass of this is 64. Okay. So given mass upon molar mass. Given mass upon molar mass, that is 1. Got it? 1 mole. 64 by 64. Given mass 64 gram. Molar mass 64 gram. 44 gram of carbon dioxide. Again for given mass upon molar mass of the carbon dioxide. Again 1 mole. Given mass upon molar mass 48, and molar mass of O3, ozone, is 16 into 3, that is 48. Again 1 mole. Okay. And 8 gram of H2. H2 is having a molar mass of 2 and given mass is 8. It means 3. See, 1 mole, 1 mole, 1 mole, 3 mole. So option number 4 is the right answer for question number 20. Sir, option number, sir, option C, sir, option 1. Unnati, you are giving wrong answers. Okay. Priya, 24, 24, 24. Very good. 24. Priya first, Aishu second, Kanishka third, and fourth, Nandini Priya. Okay. Let's go on to the next question, guys. Okay, try not to see the questions. Okay. The amount of copper in grams that can be. Amount of copper in grams that can be obtained from 100 gram of copper sulfate. So first of all, what is the mass of copper? What is the mass of copper, guys? Answer me. Ask yourself first, what is the mass of copper, and then you will be able to. I think it is somewhat around 63, I guess. Mass of copper. Think about this. We are right now question number 21. We have got 9 questions left. Okay, try to be in the session. For those who can't understand, I will tell you the mass of copper is 63, or you can take it 63.5. Okay, I am getting messages. Okay, 63.5 is the mass of copper. So it is asking 15, 14, 63.5. Okay, let's see who has given right ups. Okay, anybody else? Unnati, Priya, Aishu, Kanishka, anybody else? Time's up, guys. Okay. Now, the amount of copper in grams that can be obtained from 100 gram of copper. 100 gram of copper sulfate. Okay. So, we want to know how much amount of copper in grams, okay, you can get that can be obtained from 100 gram of copper sulfate. Okay. That's it. First, we need to find how much moles of copper sulfate is there in 100 gram of copper. Okay. We can just find percentage, right? Simple. We can find percentage, how much percentage of copper is there in the copper sulfate. So, same amount of mass will be there. Okay. But I will not do it indirect, you will get confused. So, what is the mass of, so somebody is saying, okay, 21, 2. Priya Jyoti is saying 21, option number 2. Nandini 21, option number 2. Unnati, option number 2, 63.5. Okay, good. Let's see. 63.5. Okay, plus mass of 32 plus 16 cross 4. Okay, right? This is the total mass. So, what is the total mass? I will just calculate it. Look, I am using calculator, but you are not allowed to use calculator in exam. 63.5 plus 32 is the mass of sulfur plus 16 for the 64. Okay. So, around 159, or you can say 160, okay, is the mass of this particular compound, okay, among which 63.5 is the mass of copper Okay, this is the mass percentage in this. Okay, so in 100 gram, you just have to multiply, okay, with the 100 gram. So this will be your answer. Mass ratio into the mass. That's it. You will find your answer. So let's see what is the answer. Divided by 160 is equal to 39.6, 39.6 or something. So this is the right answer. Okay, option number 2. So let's see who was right. Unnati, you are right. Kanishka, you are right. Priya, you are right. Okay. Okay, next question. Question number 22. The molecular mass of the glucose. Hey, it's very easy. I'll not give you time for this. C6H12O6. What is the molecular mass of glucose? Not giving time for these easy questions. Okay. C6, carbon's mass, 12 times the mass of hydrogen, 6 times the mass of oxygen. Mass of carbon is how much? Sir, 12. Mass of hydrogen is how much? Sir, 1. Mass of oxygen is how much? Sir, 16, sir. Okay. Then you add all this, you will get 180. You should remember this. Glucose is always having a mass of 180. Remember, 180.162 is the nearest answer. You should mark this up. Okay. How many people are there in the chat? Okay. Say your name. Option number 4 is right. Okay. Try to write answers with the question number. Okay. That's option number. Okay. Question number 23. Five moles of AB2 weight this much kg. Okay. Fourth. Very good. Very good. Wait. Is your answer really fourth? Fourth. Fourth is the right answer. Good. Good. Priya, fourth is right. Unnati, you are writing your name. Good. Okay. I ask you. Anybody else? Right. What is the answer for question number 3? 23. 22 option number 4. Yes, you are right. 22 option number 4. I am receiving the chats, okay, because there is a 1 minute lag. 16, 15, 14, 13, 12. Okay, 9, 8, 7. Okay, I am setting timer again. Now let's start doing this question. Okay, 5 moles of AB2 are weighing this much amount of gram. See, it is 10 to the power minus 3 in terms of kg. So I am going to convert it into grams. So it is 125 grams. Okay, so 5 moles of AB2 is equal to 125. So 1 mole of AB2 is equal to 1 mole of AB2 is equal to how much? 125 by 5 is 25 grams. Okay, got it? 23 option number 3. 23 option number 3. Let's see. And 10 moles of A2B2 is 300 gram. So 10 mole is 300 gram. 1 mole is 30 gram. Okay, 30 gram. The molar mass of A and B are how much? Okay, see, 1 A is adding. Okay, and here 5 gram is adding. So obviously the mass of A is 5 gram. So mass of A 5 gram. Mass of A is 5 gram. That is the answer itself. You can see none of them is correct. Incorrect. Option number 3. So see who is right. Kanishka first. No. Okay, you are 22. You are answering. Good. Priya Jyoti 23 option number 3. Kanishka 23 option number 3. Correct? You are right. You guys are right. Now let's go on to the next problem. Okay, we are reaching through the end. Just you are about to go at last. Okay. Timer start. Okay, the number of atoms in 560 gram of Fe. I am not going to give you like time for this question. You start doing it right now. Okay, I should give you time. Sorry, but not that much. Okay, lesser time. 30 seconds is like okay. Oh, Reshma Saryam. Okay, welcome to the class, Reshma. Reshma, try to answer the option. Wait. Okay, Priya Jyoti, 24. Option number 2, the number of atoms in 560 gram of Fe. 560 gram of Fe, okay, Fe is having a mass of 56 gram. So what is the number of moles? 10 is the number of moles. Given mass 560 upon molar mass 56 is equal to 10 number of moles of Fe. So 10 moles of Fe. So 70 gram of nitrogen. 70 divided by given mass, how much? 7, that is 10. Okay, good. 20 gram of hydrogen. 20 gram of hydrogen. So 20 greater 1 is how much? 20. Okay. So it's N, it's H. Okay. So we have 24, option number 3, option number 3. Okay. Okay. Twice that of 70 gram. Okay. 70 gram of N. 560 divided by 56 is 10 moles. Okay. So it is twice that of 70 gram of N2. You guys are thinking it as N2, right? Is there something wrong in the problem? Because N, it can't exist. See, there is some typo error, I guess. Okay. If we take it as N2 and N2, that's how they exist. So 70 divided by, wait, oh sorry, I am doing wrong. 70 divided by 14, okay. So we cancel this up and this is 10, this is 2 and this is 5. So twice that of 5 moles, it means 10 moles and we are right, 10 moles, okay, good. Option number 1 can be the right answer. Half that of 20 grams. So 20 gram of hydrogen is 20 moles and its half is how much? 10 moles. So both option number 1 and 2 is the right answer. Let's use right. 24, option number 3, Priya Jyoti. 24, option number 3, Kanishka. Okay, you guys are right. Now let's go on to the next problem. Okay. Incorrect statement among the following is, tell me the incorrect statement among the following. Oh, I don't have some space in here, right? I will start the timer and I will, okay, timer is being there, 1 minute. 25, tell me what is the answer for 25. Incorrect statement you have to find. Okay. Incorrect statement among the following is, which one is the incorrect statement? 25 seconds is left. Priya, Kanishka, Reshma, anybody? Okay, Reshma, try to answer with the, okay. Four, 5, 4, 3, 2, 1. Read the first option. Molar mass is the mass of 1 mole of a substance in grams. Yes, molar mass is the mass of 1 mole of any substance in grams. Got it? That's it. Option number 1 is statement is right. Option is incorrect. We have to find incorrect statement. Okay. So let's see this statement is correct or incorrect. Okay. 24. Still, Kanishka, anybody answer the question? Okay, incorrect statement among the following is, now 1 mole is the amount of substance that contains as many particles or entities as there are atoms in this much. Okay, we know 1 mole is having Na number of particles. Okay, let's see this thing is equal to Na number of particles or not. 0.012 kg, it means 12 gram. 12 gram of 14 carbon. No. 14, this is carbon 14, so this should be 14 gram to make it 1 mole, but it is asking us about 1 mole and this is not 1 mole, so this option is incorrect, hence this is the right option. Okay, got it? Option number 2 is the right. Okay, 24, nobody has answered 25, why? Guys answered 25, nobody got it? Okay, second is the right answer. Okay. Let's see, where's my mouse? Okay, here is it. How many sulfur atoms are there in 3 gram of iron pyrite? 3 gram of iron pyrite, how many sulfur atoms are there? First find the number of moles. Okay, I'll set a timer. Very less time. Okay. Anybody answer the question? Is there something wrong with my internet? Kanishka, Priyajyoti, where are you? You guys are not answering. Answer this question number 26. Okay, somebody who's watching this recording. Okay, you guys try to answer. 3, 2, 1, done. Okay. Now, how many sulfur atoms are there in 3 gram of iron pyrite? 3 gram. So, total mass is 120. So, 3 gram divided by 120. Given mass upon molar mass. Okay, divided by 4. So, 1 by 40. So, 1 by 4 is 0.25. 0.025. So, how many sulfur atoms are there? See, we have found out the number of moles of this much thing. Okay. But in this one molecule, there are 2 sulfur atoms. So, in this 1 mole, there will be this much number of moles of sulfur. Okay, twice that of FeS2. Number of sulfur moles is twice that in FeS2. Number of moles. Got it? Okay, that's why you multiply by 2. So, multiply by 2, 1 by 40, 1 by 20, 1 by 20 is 0.5, 0.05. Okay, you have to multiply by 0.05, you have to multiply this thing. So, 5 into 10 to the power minus 2, that is 0.05 moles, into 6.022 into 10 to the power 23. So, 23 minus is 21, okay, 10 to the power 21, 5, 6 is 30. So, 30, I will write it as 3, not 30, and I will make it 22. So, 3 something 10 to the power 22, 3 something 10 to the power 22, okay. So, sir, 26 option number 3, 26 option number 3, 26 option number 3, very good. Okay, so Priya Jyoti, you are right, Kanishka, you are right, and third person is Priya. Okay, Reshma Saryam, you are writing 6. I can't understand which option is 6 because we only have 4 options. Okay, got it. Okay, so Priya, you are on the top, then Kanishka, and then Priya. Okay, there are 2 Priyas, Nandani Priya, and then, okay, I'll call you Nandani. How many millimoles of methane CH4 are present in 6.4 gram of this gas? I will not give you time for this question. Why I am pressing timer button? I should just write it. 6.4 gram given mass upon molar mass, that's it. Molar mass of CH4, what is the molar mass of CH4? Sir, carbon is 12. Sir, hydrogen is 4. Okay, 12 plus 4 is 16. So, you divide by 16. Given mass upon molar mass, and you cancel this up, you will get 0.4. Okay, so 0.4, 0.4, 0.4, 0.4, this is 0.4. Okay, option number 1 is the right answer. Okay, Reshma Saryam 26.3, very good. Try to answer it like this. Okay, 27 is done. Okay, there is a 1 minute lag, so I might be taking your name a little later. Okay, so let's do this question. Set that timer. I will give you a good time for this question. Okay, just little 30 seconds extra. Okay. Okay, 20 seconds is enough for you guys. Okay. Now, given is the following equation: tin oxide reacts with hydrogen to form tin and water. What volume of hydrogen measured at 1 atm and 270 STP? 1 atm, 273 Kelvin. STP. Got it? (27) option number 4. Hey, 27 option number 4 you are saying, Priya? Oh, sorry. Option number 4 is right answer. Okay, Priya, you are right. Option number 4 is right answer because it is asking us about millimoles. Okay. Now we are on the third question. We have 3 more questions. Okay. Priya, you are right. Okay, I had given you wrong answer. Okay, it has asked us about millimoles. Okay, so you have to multiply that number with 1000 to get number of millimoles. So, what volume hydrogen measured at this is required to react with 2 gram of SnO2. Okay, simple. 5, 4, 3, 2, 1. Okay. Priya, your answer is right. Okay. Now let's do this question. Okay. Okay. Given is the following equation. Okay. So this is the reaction. Everything is at STP. Okay. Is react with 2 gram of SnO2. See, what volume of hydrogen? So before you find out volume, find moles. Okay. So if there is 1 mole of SnO2, 2 mole of hydrogen is required. Okay. So let's calculate how many number of moles are there. So if there are x moles of SnO2 present, 2x moles of hydrogen is required. Okay, got it? So we need to find the value of x. So x is equal to, okay, never found out the value of x. Okay, 2 by 150. Okay, 2 is SnO2 and this is the given mass upon molar mass. Okay, this is the value of x. Okay, so you again multiply it with 2. Whatever the number of moles that is required with SnO2, they are present for SnO2, twice that of thing is required to react with the hydrogen. Okay, so multiply it with 2, okay, and by 150, and okay, now we have to calculate the what is the volume. Sir, I guess 28 is 4. Yes, 28 is 4. I'm just seeing your chats a little later. Yes. Okay. Now 4 by 150. Now when you want to find out the volume, okay, how can you find out volume? This is the moles given. Okay, to find the volume, 1 mole is equal to 22.4 liter. So this much number of moles is equal to this much amount of liters of volume. Got it? So this is the answer. Let's try to calculate this answer. Okay, calculator, 4 into 22.4. So 4 into 22.4, 89.6 divided by 150. 0.59 something. Okay, so this is the right answer, option number 4. Let's see who has given the right option. Okay, nobody has answered. Okay, sir, I guess 28 is 4. Okay, Nandini, you are answering for the previous question. So Nandini, this time Nandini, you are the first one to answer this question. Okay, congratulations. 28, option number 4 is the right option. Okay, now just last 2 questions, guys, bear with us. Okay, and the total number of electrons present in 1 gram of C2H4 is, it's very easy. Okay, very easy. Just start the timer. Okay, start. Okay, 29. Total number of electrons present in 1 gram of C2H4 is 28, option number 4. Kanishka, you are also right. I'm talking, okay, right now 29 question is going on. The total number of electrons present in 1 gram of C2H4 is, so how many number of electrons are present in hydrogen into plus number of electrons present in carbon. Okay, so okay, Unnati Kishore, okay, 29 na? Unnati Kishore, 28 for the option number 4. 28 question number, option number 4 was the right option. Okay, Priya has answered 29 third option and 29 second option. Okay, good. 29 third option, 29 second option. Let's see who's right. Now Priya has changed his answer to 29 option number 2. Let's see you are right or not. Now mark. Total number of electrons present in 1 gram. Okay, given mass, what is the molar mass of C2H4? 28. So this is the amount of moles. Okay, now we, for 1 molecule of this thing, okay, for 1 mole of this thing, how many moles of electrons are present in there? We have to calculate this. 2 into number of electrons in carbon. Okay, so what is the number of electrons in carbon? Tell me. Number of electrons in carbon, sir, and 4 into number of electrons in hydrogen, that is 1. Okay, carbon, why I am forgetting this thing. Carbon is 12, 12 to 6, therefore 4. Okay, 4 to 8, 8 plus 4 is 12. So 12 is the total number of electrons. 1 mole of C2H4, 12 moles of electron. this much amount of C2H4, this much moles of C2H4 into 12, because we have to multiply, right? So it's cancel this out, it's 14, 12 is 6, again cancel 3 by 7, somewhat 3 by 7. Let's see what is 3 by 7. 0.042. Okay, wait. Total number of electrons. Oh, we don't have to. Number of. Okay, we have to find number of particles. Got it, got it, got it. So 3 by 7, 0.6, 6.02. 0.25. Wait. I am doing this wrong. Okay. First of all, what is the number of moles? 1 by 28. So am I right? 28. 12 to 24, 25, 26, 27, 28. Okay. 28. Number of moles into number of particles of this particular C2H4, and in each particle, how many electrons are present? 12. Okay. So then this is the right answer. So we have to do this. 12 into 6.022 into divided by 28 into 10 to the power 24. Okay, got it. So 12, just multiply it. Okay, so 12 into 6.022 and divided by 28. Okay, 2.58 into something. I think 2.58. I am not getting any answer. 2.58. Think about this. Is this the right option? Wait, let me check. Is this? Because none of this, it's very hard to tell any answer is none of these. 3.44 into 23, somebody's answer. Wait, 29 option number 2, 29 option, okay. Might be 29 option number 2 is the right answer, but I am doing wrong. 12 by 28, what is the ratio of this thing? Into 6.022, 6.022. Okay, what I am doing something wrong. Can you tell me guys what I am doing wrong? The total number of electrons present in 1 gram of C2H4. 1 gram of C2H4. Uh, 1 gram of C2H4. Am I doing something wrong? Okay. Na, okay, 1 by 28, 12 into 6.022, 10 to the power 23. I am doing something wrong. Can you guys let me know? Kanishka, Priya, is there anything wrong with my solution? Because I am getting a different answer. Total number of electrons present in 1 gram of this C2H4. Okay, so number of electrons in that is, carbon is how much? Carbon is how much? Wait. 12 divided by 2 is 6. Is 6 to get 12? Okay, 12, 13, 14, 15, 16. Okay, this is wrong. 16. 16 is the number of that what we need to multiply. Okay, then if you multiply 6 by 28, okay, that's where I was getting wrong. So 16 by 28 is 0.57 into 6.022. Okay, so this number is 3.44. So option number 2 is right. I got the total number of electrons to be wrong. Okay, that's what I was not able to get. Okay, so last question of the day, guys. Finally, we are at this end of the session. Okay, do this problem. Little bit more time to you. Do this problem, guys. Match the mass of elements given in column 1 to the number of moles given in column 2. That's it. Okay. Try to answer this, guys. I think this question is easy. We don't need some time for this. 28 gram of helium, 46 gram of, okay. First of all, 60 gram of calcium. Okay, so calcium is having a mass of 40. So 60 by 40 is what? 6 by 4. 6 by 4 is 3 by 2. 3 by 2 is 1.5. So this is option number this. Okay. 60. This is 1.5 mole. Okay. So option number C is going to be fourth. C is going to be fourth. So option number 4 is the right answer itself, because none of the options are these one. Okay. C is 2. No. Okay, got it. We are right. Now, I guess option number D is the right answer. That's it. Okay. So we can finish our session over here. You will get this PPT, okay, in the group itself. You can join our WhatsApp group, and that is it for today. Take care. See ya. Bye bye, and have a nice day.